In this lecture, we'll be discussing going about finding absolute extrema, absolute maximums and absolute minimums. There are three places where we need to consider absolute extrema existing. So, given some closed interval, the absolute maximums or minimums can occur at 1, the endpoints, so we always will need to test those when we're looking for absolute extrema. Right. 2, where the derivative equals 0, and 3, where the derivative does not exist. So we'll have to consider all three of these locations in order to identify both where the absolute mins or maxes occur and what the absolute maxes and mins are. In example 1, we're being asked to consider the function 3x squared minus 24x minus 1, and we're considering it on the interval -1 to 5. So let's first get all of the x values where we need to look. We have our endpoints. Let's consider the derivative. The derivative of our function is 6x minus 24, and this will equal 0 when x equals 4. And the derivative always exists. So there are three possible places for absolute minimums and maximums. One of them is at f of -1. The second one is at f of 4. And the third one is at f of 5. At this point, we're just simply going to substitute in -1, 4, and 5 into the original function to come up with what must be either the minimum or the maximum. When we plug -1 in, we'll end up with 3 plus 24 minus 1, which has a value of 26. When we plug 4 in, we end up with 48 minus 96 minus 1, which has a value of -49. And finally, when we substitute 5 in, that will be 75 minus 120 minus 1, and that will have a value of -46. This means that if we want to know where the absolute maximums and minimums occur, the absolute max occurs at x equals -1, and the absolute minimum on this interval occurs at x equals 4. If we want to know what the absolute maximum and minimum are for this function, then the absolute maximum of this function on this interval is 26, and the absolute minimum of this function on this interval is -49. And we'll look at a few more examples. So a different example, our function is 6x cubed minus 6x to the 4th plus 5, and we're considering this function on the interval -1 to +2. So we have our endpoints. Now we just need to see where is the derivative equal to 0 and where is it undefined. Our derivative is 18x squared minus 24x cubed, and I'm going to factor this, and this will factor into 6x squared times 3 minus 4x. So the derivative will equal 0 when x equals 0 or when x equals 3/4. And the derivative is always defined on our interval. So we need to consider 4 points: f of -1, f of 0, f of 3/4, and f of 2. F of -1 has the value -7. F of 0 has a value of 5. F of 3/4 or 0.75 is about 5.633, and f of 2 is -43. So we can see that the absolute maximum of this function occurs at 3/4 and is 5.633, and we can see that the absolute minimum of this function occurs at 2 and is -43, at least on this interval. Let's consider 2 more examples. So we've got the function 3x to the 2/3 minus 2x plus 1 on the interval -1 to 8. We've got our endpoints. Let's figure out where the derivative equals 0 and where the derivative is undefined. The derivative would be 2x to the -1/3 minus 2. And this might be easier to consider as a cubic. So 2 over the cube root of x minus 2. And we'd like to know when this equals 0 and when this is undefined. Now this will be undefined if x is 0, because that will cause us to have 2 divided by 0, and we can't have that. So our derivative is undefined at x equals 0. If we figure out when the derivative equals 0, that will happen when 2 over the cube root of x equals 2, and that will happen when we'll multiply both sides. So 2 equals 2 times the cube root of x. Can't see it already. Divide by 2. The cube root of x equals 1. Cube both sides when x equals 1. So again, our derivative is undefined at x equals 0 and is equal to 0 at x equals 1. So we'll have to check 4 points. What is f of -1? What is f of 0? What is f of 1? And what is f of 8? Testing these. F of -1 equals 6. F of 0 equals 1. F of 1 equals 2. And f of 8 is -3. So we can see that the absolute maximum occurs at -1 and is 6, and the absolute minimum occurs at 8 and is -3 for this interval. For our last example, our function is sine squared x plus cosine x on the interval 0 to 2 pi. We have our endpoints. We need to consider when the derivative is equal to 0 and when the derivative is undefined. The derivative of sine squared x would be 2 sine x times cosine x using the chain rule. So again, 2 sine x times cosine x using the chain rule, and the derivative of cosine x is negative sine x. This will always be defined, but we need to figure out when it equals 0. If I factor out a sine x, this will become sine x times 2 cosine x minus 1 equals 0. The sine of x equals 0 on this interval. Sine is 0 at x equals 0 and at x equals pi. 2 cosine x minus 1 will equal 0 whenever 2 cosine x equals 1, or whenever the cosine of x is 1/2. On this interval, this will occur when x is pi thirds and when x is 5 pi thirds. Again, this is where it's really important to know your trig identities. So again, pi thirds, which is 60 degrees, or 5 pi thirds, which is 300 degrees. So we have quite a number of points to check, but not too many. We need to know what is f of 0, what is f of pi thirds, what is f of pi, what is f of 5 pi thirds, and finally, what is f of 2 pi? So let's start with f of 0. The sine of 0 is 0. 0 squared is 0. The cosine of 0 is 1. So f of 0 is 1. F of pi thirds. Well, the sine of pi thirds, or 60 degrees, is root 3 over 2, and squared will be 3/4, plus the cosine of pi thirds is 1/2, so 3/4 plus 1/2 would be 5/4. If we test pi, the sine of pi is 0, the cosine of pi is -1, so f of pi would be -1. If we test f of 5 pi thirds, the sine of 5 pi thirds would be, let's see, so it's related to 60. The sine of 60 was root 3 over 2, so it would be negative root 3 over 2, and squared, this would be 3/4. The cosine of 5 pi thirds is 1/2, so again we end up with 5/4. Finally, 2 pi. The sine of 2 pi is 0. The cosine of 2 pi is 1. And we have 1. So in this case, we have an absolute minimum on our interval at pi. And we have two places for the absolute maximum. One of them is at pi thirds, and the other one is at 5 pi thirds. There are your examples on finding absolute maximums and minimums. And the key thing is just knowing where you need to look. You must always check the endpoints for absolute max and mins, and you must always check wherever the derivative equals 0 and wherever the derivative is undefined.